This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 1, Load Fundamentals. Before we chase individual heat gains, we set the frame, what a load actually is, and how every load splits into a sensible part and a latent part. Then the 3 standard air factors that turn an airflow into a load, and 1 clean worked split. The sensible heat ratio that ties the two together got its own lesson back in Week 1, Lesson 8. Here, it just falls out at the end. A load is the heat you must add or remove to hold a space at set point. On the winter design day, you replace heat lost through the envelope and to cold air, mostly sensible. On the summer design day, you remove heat and moisture gained from the sun, people, lights, equipment, and outdoor air, both sensible and latent. The driving difference is the design delta T, indoor set point against the outdoor design condition. The handbook prints no climatic design table, so take those outdoor values as given. Every load splits 2 ways. Sensible heat changes the dry bulb temperature. You feel it as hotter or colder air. Latent heat changes the moisture content, the energy tied up in adding or removing water vapor, felt as humidity, not temperature. Total is their sum. They use different factors and different driving differences, so keep 2 ledgers and add at the end. The sensible share of that total is the sensible heat ratio. Week 1, Lesson 8, covers how it sets the slope of the psychrometric line. 3 standard air factors turn an airflow into a load. Sensible is 1.10 times the CFM times delta T. Latent is 4,840 times the CFM times the moisture change. Total is 4.5 times the CFM times the enthalpy change. Watch the 2 Q's. Capital Q sub S is the standard airflow in CFM. Lowercase q sub s is the sensible load in BTU per hour. Use 1.1 for standard air. The problem. 3,000 CFM of standard air, a 20-degree dry bulb swing, and a moisture swing of 1,000th of a pound per pound. Find the sensible, latent, and total loads, and the sensible heat ratio. Sensible is 66,000. Latent is 14,520. Add them for a total of 80,520. Sensible over total is 0.82, about 4/5 sensible, 1/5 latent, a normal comfort split. Traps. 1. Each factor carries 1 part, 1.1 the sensible on temperature, 4,840 the latent on moisture, 4.5 the total on enthalpy. 2. Never cross them. Feeding delta T into the 4.5 total factor is the classic mix-up. 3. Design conditions are a choice, not a handbook table, so no citation. 4. Carry sensible and latent separately and sum only at the end. 5. The flow is standard CFM. Actual airflow at odd conditions breaks the packaged constants. Quick recall. A load is heat added or removed to hold set point, and it splits into sensible and latent. Sensible is 1.1 times flow times temperature change. Latent is 4,840 times flow times moisture change. Total is their sum, or 4.5 times flow times enthalpy change. The sensible heat ratio is sensible over total. The Week 1, Lesson 8 topic. Next, Lesson 2, Envelope Conduction Loads. We build U factors from the handbook's resistance tables and push heat through walls, roof, and slab with Q equals U, A, delta T. Everything's at peprepengine.com. Cheat sheet, worked solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.